Hello everyone, this is Jose from macroAPIs.io, and in this video we're going to learn to validate tokens issued by Auth0 to authorize access to our APIs. So in previous two videos we learned to configure Auth0 to be able to manage access to our APIs, and we also learned to create a login flow to be able to log into our APIs using Auth0 and to issue access tokens for our APIs. The question now is, how do we validate those access tokens? And that's what this video is all about. As you will see, it doesn't take much. It's just one function, one validate function to validate those tokens, and we just need to inject this function using dependency injection in FastAPI into every endpoint that is authenticated. Throughout the video, you are also going to learn about the background and the mechanics behind these type of tokens and the validation mechanisms involved in them. And by the end of the video, you will be set to go to add robust authorization and authentication to your APIs. I am very excited to share all this knowledge with you. And so without further ado, let's get on with it. All right, so in the last video, we implemented a login and a token endpoints. And so with the login, we go through the flow of authorizing a request, and in the token endpoint, we exchange the authorization code for the token. Now the question is, how do we validate this token in the backend? And so to answer that question, let's look at the token again. So if we run the server here in the terminal, so let's say ubicon server reload. Okay, and now we're going to go through the login process again. This is the UI that we implemented last time. We're going to have in another tab, we're going to do the login. So we do that. And this is the token. Now remember, for access validation, we are always going to use the access token, not the ID token. And so if we go to jwt.io, we paste the token here. And we see the token comes in three parts. They are separated by dots. And so the first part is the header, and then we have the payload, and finally we have the signature. If you want to learn more about the theory of tokens and everything that is behind them, I have a video dedicated to that. In this video, we're just going to see how we validate these tokens from Auth0. So in the header, we have information about the token. So it tells us, for example, this type property here, it is telling us that this is a JWT token. And we also have information about the signing algorithm that we used for the token and something called KID. So this is actually key ID. It's the ID of the key that was used to sign the token. We're going to come back to that in a minute. And then we have claims about the user, right? Remember, those are claims about the right of the user to access our website or our API. And so we have the subject identifier of the user. Remember, this token is going to come back and forth between the server and the client many times. It shouldn't contain any identifiable information. And so the subject should be something like this that is not clearly relatable to an identifier. Many times I see things like emails that, it's very common, but it's not really the good practice here, because if the token gets leaked, that is personal identifiable information that is leaked. We have information about the intended audience of the token. And so what is the API that this token has been issued for? And so in this case, this is the orders API and the user info API. What this means is that we will be able to use this token actually to make a call to the user service in Auth0 to retrieve additional information about the user. The one we are interested here is the orders API key here. All right, that audience. And so we're going to have to validate that in our server to make sure that we are receiving the right token to access the API. We have information about the expiry date of the token, the scopes that were used to retrieve the token, and the role of the user. Now, these are the claims. The most important part of the token really is the signature. That is what tells us that the token is legit. And so the first thing we have to do is to validate that signature. Now, that signature, we have the information in the header, was used to with the RS-256 signing algorithm. So if you remember from one of the previous videos, we can sign tokens using various algorithms. The most common ones are RS-256 and HS-256. Those are RSA and HMAC. HMAC is with a password. RSA is with keys. So these are a private key and a public key. We use the public key to verify the signature. Now the good thing is the public key is public, anyone can access it, nobody can do anything with it. To sign the token you need access to the private key, which lives in Auth0 and doesn't leave the server. So that is the first task, to find out where we can find that public key. Now this, remember also from the previous video, this is all built on top of the OpenID Connect protocol. You know, the original idea of this protocol is how can we help users bring their identity from certain services to other websites? So how do we bring our identity from Gmail, for example, or from Facebook or from Twitter to other websites, so that we don't have to create a new account and manage different passwords and everything. And so that's OpenID Connect. And this is a standard. All OpenID providers follow more or less the same pattern to tell you what are the authorization endpoints, how it works, where do you find the keys, and so on and so forth. And so for Auth0, the first thing we have to do is to find the authorization domain. And so we go to applications, and here in applications we find the orders UI client that we created earlier, and here we have the domain. Now the information about how the OpenID Connect endpoint here works is going to be available on /.well-known and then / and we have something called OpenID hyphen configuration. And this is everything we need to know about the OpenID configuration in Auth0 to be able to interact with it programmatically. And so if you understand this information, you can build your integrations directly on top of this. The part that we're looking at is the JWKS URI. So this is where the keys that we need to use to validate the tokens exist. All right. So this stands for JSON Web Token keys. And so, you know, the good thing about this is, although RSA keys are fairly secure, it's not entirely impossible that someone might be able to break them, or even the key gets leaked for some reason. And so it's good practice to actually rotate those keys. And so what we need to do in our service is, instead of having a hard-coded reference to the keys, is we need to pull them every time that we start the service, or, you know, when we know we are going to rotate the keys, we tell the service you have to reload them. And so we're going to pull the keys always from this endpoint. So if we visit this URL, we have a bunch of keys here. Each of them has a key ID, right? A key ID. And so one of these is going to match what we have here. So if we copy this ID and we find it here, right? So this is the key. So we're going to use this information. We're going to feed it into Python Jose, which is the library we're going to use here. If you check PyProject, we have the dependencies of UbiCon FastAPI requests. We're going to use requests to pull these keys from the remote server. We're going to use Python Jose to validate the token. So that's the first job, to find those keys and use them to validate the token. Now, I just want to show you how this information is actually fairly standard. So you will find a similar OpenID configuration endpoint on Gmail. So if you go to accounts.google.com/well-known OpenID configuration, you have the exact same information here. So you're going to find something like this in all or most OpenID providers. Now back to Python. How do we validate these keys? Let's create a function here. First of all, we're going to create a function to validate the key, and then we're going to see how we put that into FastAPI to validate access on every request. So the first thing we want to do is to put this JWKS endpoint here. So that's the one we visited before here, this URL, the one here. So that's going to be our variable here, and we're going to pull those keys. So we're going to say the JSON Web Token keys are request get JWKS endpoint JSON keys. Okay, so that's going to be our keys. If we put a breakpoint here, right, that's going to stop the server. If we put the JWKS variable, we have the keys here. Now we have to iterate over these keys to find the one that is going to match our token. So let's create a function for that. So we're going to say find public key, and the parameter is going to be the key ID. And then we say for key in JWKS, if key ID equals the key ID, then return the key. All right, so that's the first step. We have a function now that can find the right key for our token. And then we have to validate the token. So we're going to create a function for that. It's going to be validate token. And it's going to receive the token. And what we're going to do is we're going to say, remember, we have to find the key ID, right? The key ID. And that's going to come from the header. The way we obtain the header from the token is using Python Jose. We're going to decode the headers. So if you know about the theory behind this, so these are all JSON documents. So JSON document for the header, JSON document for the payload. Both of them are base64 encoded. So Python Jose is going to decode that base64 encoding for us so that we can access the dictionary that represents the header. So we say JWS get unverified header, and that is from the token. This comes from Python Jose, and then we have to find the key from the header. So the header is going to look like this, as a Python dictionary, and so we can say the public key is find public key. We have the function takes the key ID, so that comes from a verified header, the key. Unverified header is because we haven't verified the signature yet. It's all it means, okay? And we're gonna access information about the token before we validate it, because we need to know what's the key ID. All right, so that's the key ID that we are using to find the public key. And now to validate the token, we say JWT decode, and this decoding function is going to decode the payload and also validate it at the same time. So it's gonna do the two things simultaneously. So we're going to say token is the token, and then we have key is the public key, and then we have the audience. We have to validate as many claims as we can in the token. Those claims are here in the payload because we want to validate them. So Python Jose is going to take care of some of these things on its own. It's going to validate mostly the expiry date. Then it's on us to make sure we are validating as much as we can of the other information. So at the very least, we want to validate the audience. And the audience here is, remember, API threads, this URI. So that's the representation of the API that we had in the APIs, right? So this is coming to the orders API, which has this identifier. So that's what we are putting here in the audience. We import this also from Jose. Jose, by the way, stands for JavaScript Object Signing and Encryption. There is an RFA about that. I'm leaving it in the description of the video if you want to learn more about it. That's what it stands for, and so it's a collection of ideas and protocols on how to manage signatures in JSON Web Tokens. So that's why this library is called like that. Python Jose doesn't have anything to do with the actual person name, it's just this standard. Right, so we have the audience and then the algorithms that are used to sign the token, and we can fetch that from the header, but that's something I actually recommend to hard code. The reason why is because you have control over the signing algorithm. In the first video of this series, we configured Auth0 to use a specific algorithm to sign the tokens, and so we have control of that. We want to make sure that all the tokens that are coming here are correctly signed with the expected algorithm. So, all right, this is all we need really here to validate the token. If the token is invalid, this is going to raise an exception, and we will handle that in a moment, but let's see how this works first of all, right? And we're going to create an endpoint for that. We're going to create a server get, let's say, protected. It's a protected endpoint, and we're going to do this properly in a moment. I'm just showing you step by step how how it works, so that you understand the basic mechanics, so that when we put it all together, it may look complex, but you understand the basics, right? And how everything is coming together. So this is a function protected. And what we're going to do is we're going to accept the key here as a query parameter. It's not the best practice at all, but just to have a way to pass it to the function. So we're going to say key is a string. It's going to be the JSON Web Token. And what we're going to do, see what we have here is actually the token payload. This decode function is decoding the payload, is validating and decoding. So we're going to return that payload. And what we're going to do here is we're going to return all of these. So the token is the key. Actually, let's call it token. And so, you know, if the token is valid, it's going to be validated and we're going to get the payload back. The payload is going to be this part here. So just a simple way to get this working. So we do this here and then we fetch the access token from here. We're going to try out this endpoint. We put the token here, and if we send this to the server, we have an internal error, which is right there. We got wrong. This property name is KID, it's not ID. So if reload it, if we send the request again, the token is valid because we did things correctly, so we get the payload back. And this is exactly what we have in here in the JWT IO website. And remember, this payload is public, is simply a JSON base64 encoded, and that's why we shouldn't have sensitive information in this token, just claims about the user to access our API. The magic is in the signing algorithm. JWT.io doesn't have access to our public key here. We could put it here to make the validation. We're not going to do that, but it's simply decoding this. What we are doing in the backend here, we are validating the token and decoding the payload. Now, how do we put this all together so that we tell FastAPI that this endpoint, the protected endpoint, is actually authenticated and it should accept a better token? Better, all it means is that it's going to look like this. It's going to be an authorization header and it's going to say better, the value is going to be better, and here is then the token. Right, so how do we tell FastAPI that we have better tokens that are coming to this endpoint and we have to validate them? So we are going to do it by enhancing this function. So what we're going to do, first of all, instead of returning a raw payload here, we're going to create a proper model, okay, to represent that information. So we're going to come here and we're going to say class user claims, and this is going to be a Pydantic model. Doesn't have to be a Pydantic model, it can be a data class or something else. But if it is a Pydantic model, then it's going to do validation of the data that is passed through, and that always helps. So this is a string, and we're going to pass also the permissions. This is really the information we want to get from the token, the subject identifier of the user and the permissions the user has. Right, so we're going to return yes, we're going to say user claims sub is token payload sub and permissions from the payload as well. Right, so to tell FastAPI that we are receiving this information, these tokens here, the way to do it is using this signature. So first of all, we have to create a better scheme for the API. So it's going to be security HTTP better. All right, so this is an object that we're going to use in the signature of our endpoint to tell FastAPI that we are receiving those better tokens in the endpoint. And so here we're going to add another parameter, which is credentials. And the type of this parameter is an annotation. So the actual type is HTTP authorization credentials. So we input annotated, and we import this from FastAPI, and then we have to add an annotation. So HTTP authorization credentials, what is telling FastAPI is, hey, there is authentication on this endpoint, but now we have to annotate that with additional information about the type of authentication that we have here. And that is the authentication scheme. So that's the better scheme we declared earlier. So this boy here, HTTP better, which is assigned to this security, and actually it should be, we can call a security scheme if that makes more sense. This is how it comes from the FastAPI documentation. So to keep it in a way that is familiar to you when you look at the documentation, using the same terminology for that reason. the way it's going to come together is with dependency injection. So it depends on security. So we put it together like this. This is how we can feed the information to FastAPI so that it understands that there is an authentication scheme behind this endpoint which follows the better scheme, and putting all this together is going to re-render the Swagger UI with this authentication scheme. And it's also going to take every JSON Web Token we send to every protected endpoint, like this one, and it's going to split it between the better keyword and the token so that we have the right information to work with when it comes here. So let's put a breakpoint so that we actually can see what it looks like, this credentials object looks like. So we're going to come first here, we're going to reload, and now we have authorize here, okay? So this magic is coming from that annotation we just put on the endpoint. And we have also an indication here that the token is authenticated. So now we can grab the access token from here, we can feed it into this field here, we click authorize, we close, we expand the protected endpoint, we try out, and we put the token here as well because we are still requesting it. We execute. Now we hit the breakpoint, all right, here in the function. So we have the token in the query parameter, but we also have this credentials parameter that we included here. So if we inspect it, we see it is an object of type HTTP authorization credentials, which is the class here. So this is the type of the parameter, and this additional annotation is to tell FastAPI how do we build this object. And so we build it. Remember, I told you the token comes as a better token. So the first keyword is the scheme, is a better token, and then we have the token. Now what we can do is, we can put this annotation in all our protected endpoints. So when we render the Swagger UI, they're going to be all protected like this. And when we put the token in this authorize button here, then FastAPI is going to send the token correctly to all those protected endpoints. And it's going to parse and process the token correctly. So all we can do, let's continue here. Looks like we made some error building the claims. So it's in singular here, it should be plural actually. It should be plural. Okay, so that fixes the typo here. Now what we're going to do, we want to reuse this validate token function everywhere. We want that to be our single endpoint to validate access across all of our protected endpoints. So we're going to get this, and we're going to remove this signature, and we're going to move it here. Okay, so this validate function is going to take this signature now. And the way we're going to fit the function into our endpoint is by saying this. We say user claims is of type user claims, the object that we defined here, this Pydantic model, which is returned by this function. And so this is going to be a dependency on the validate token function without calling it, of course. And here we're going to return user claims directly. Right, so what's going on here? We are saying this endpoint has this parameter, which is not a query or a URL path parameter. It's a parameter of the function for FastAPI to know about it. And the type of this parameter is this Pydantic model, user claims. And the way we resolve the value of that parameter is with a dependency, which is validate token. So now FastAPI goes to validate token and it says, okay, what's the type of what's the interface to this function? And say, oh, okay, this is an authentication credential object, and here is my information that I need to know about how to construct that credential. And so this information is going to feed into this, and it's going to propagate into the rendering of the Swagger UI so that we still have that authentication button and we are still able to send the tokens to all those protected endpoints. So basically everything that happened manually here in the payload, in the body of the function before, is going to happen now in this validate token function. Now we just need to change this. This is now going to come from credentials. The credentials property is the one that holds the token. And here also credentials. And what we're going to do now, the tokens may be valid, may be invalid. Now, so if they are invalid, it will raise an exception. So we need to handle that. Let's first of all make sure the happy path is working. So server is reloaded. We reload the UI. We grab the token again. We put it into the authorized endpoint. Authorize and close. Try out the protected endpoint. Hit this, and the token is valid. So it's all working. Now, what happens if we put an invalid token? Let's log out. So let's just remove some characters. That's already going to invalidate the token. And we send this. Now we have a server error because we are not catching the exception. There is a validation error. The signature verification failed. So we need to handle that. So we're going to put a try except here. And if the validation fails, we're going to capture that error. So we're going to say except. We're going to capture expired signature error. So if the token is expired, JWT error, so a generic error with a JSON Web Token, JWT claims error, so any error with the claims when we're validating them, or JWS error. So we capture all of these possible exceptions and we say as error. And if there is an error validating the token, the user is not authorized to access the page. Now there are two types of responses here. We have 403 and 401. 403 is if there is no authentication at all. In that case, if we are not sending the token at all, in that case the user is not authenticated, we'll respond with a 403. If the token is invalid for whatever reason we're capturing here, then it's a 401. We can also arguably distinguish between different types of errors. It's not the same thing to have a valid token that is expired as to have a completely invalid token like the one we just sent, like a random string, for example. But for the sake of simplicity, we are going to return a common 401 response to all of these errors. So we're going to say HTTP exception, status code is 401. We import it, and then status code is 401, and then detail is the error. So we're going to explain what happened. Okay, so if we send a request now again here, now we have the information. So signature validation failed because the signature is incorrect, and the status code is 401. And so that's really all it takes to validate the tokens. We've done it, we completed the job. Now you can take this further. With this, we're just doing kind of like a first pass in authentication, which is to verify that the token is there and it is valid. The next pass, if some endpoints require some check on the user. So for example, if we are accessing a payments endpoint to retrieve a list of payments, we want to make sure we are only returning payments that belong to the user. In that case, we will check the subject property. So we are capturing that. We have access to that information here. The user claims, we have the subject here. So what is going to happen in our service is we have in the database, if it is a payment service or an order service like this one is supposed to be, every order has a user ID or something which is the subject of the token, and we don't need any additional information about the user. If we want to, we can get that information from the user endpoint in Auth0. So remember, the token has access to that API here as part of the audience. So if we send a request to the user service API in Auth0, we will obtain that information. And I'll put together a video to show you how we do that in the future. But that is what you need for now. And then also permissions. If it is, for example, an admin endpoint, we can also put a validation on that claim in the token to see if the user is an admin or not. And if they are not an admin, then we will reject the request. So there you have it. This is everything you need to know about validating tokens from Auth0 or any other identity provider. So it's going to work the same or very similar with Active Directory or Entra, with AWS Cognito, and any other provider. You're going to use the same library. You're going to validate the tokens in similar ways, and the flow is just going to be similar because they are all built on the same protocol. A couple more words here. Never cache those tokens. Don't put them on a database. Don't put them on a Redis cache or something similar. I've seen a lot of people doing that. That's not the point of these tokens. These tokens are designed for stateless validation, so when you get the request to the server, you have all the information you need in the token to determine if the user can access the operation they're requesting or not. And one final thing to say, of course, I'm hard coding all this information here. I got some feedback from a previous video. So of course, you will want to parameterize this information. You don't want to have these hard-coded values in your production application or something similar. This is sensitive information. If it shows up on your GitHub and that gets leaked, or someone gets access to the source code either in GitHub or on your deployment server or in some other way, that is very dangerous. So you will parameterize these things. You will pull that information from the environment. I just didn't do that here to keep it simple and so that you can see how all these values are coming together in the code. But that's what you will do in a production application. You will parameterize these things. And I'll put a video together also at some point to show you how we pull information correctly from the environment and all the edge cases we need to handle in that case. One final word. Of course, everything here is in one file. So we have the instance of the Fast API application. We have the login endpoint. We have application endpoint protected here. So all of those things will go into different files. Again, here is just an example. And to keep it simple, everything is in a single file, but you will have your authentication endpoint. You will have your application endpoint. You will have the authentication layer that contains all this logic necessary to validate tokens and access and so on and so forth. In a bigger project, and I have videos about that already, and I have courses and so on, you can see how to structure this in a better way. The point here wasn't to teach you that, it's just to learn to validate those tokens. So this was already a long enough video. I hope that was useful. If you have any questions at all on this process, please let me know. Put the questions in the comments. I'm trying to help as many people as possible to get authentication and authorization right in their APIs. And if there's anything else you want me to cover in relation to this topic, please let me know in the comments and I'll make a video for that. All right, so that was everything. If you like this video, please subscribe to the channel, make a comment. If you're interested in learning about other topics related to Fast API, Python, or APIs or web development, please leave your suggestions in the comments. Share this video with anyone who might benefit from it, your colleagues, your friends, or family. And if you want to learn more about API and web development in general, or working with Python or API security, check out my website, learn.microapis.io. I'm currently working on a whole series of courses about API and web development. I'm going to be uploading them very soon. And so if you want to learn more about these topics, check out the page. And if you have suggestions or you wish me to create courses on specific topics, leave your suggestions in the comments and I'll see what I can do. Thank you so much and see you soon.